Good morning friends. Next our experiment is superposition theorem. So here in this kit both superposition theorem and reciprocity theorem both are available only in this kit. But here we are going to do only first superposition theorem. Okay, but this is a reciprocity theorem. We are not doing this reciprocity theorem right now. We are doing only superposition theorem. So according to this circuit here, you remember this one is a bilateral network. So in this bilateral network we have two voltage sources, V1 voltage source and V2 voltage source. So these V1 voltage source and V2 voltage sources in both the ends, and here resistance is 82 ohms and R1 resistance is 82 ohms and R3 resistance 100 ohms and R2 resistance 47 ohms. Only for these resistances only I am going to calculate the theoretical calculation, then we will come back to do a experiment practically. Okay, you remember here this is the theoretical calculations for superposition theorem. Okay, here according to statement it states that in any linear bilateral network consists of two more energy sources, the response in any element is equal to the algebraic sum of the response when individual sources are acting alone while the other sources are inactive. For some students it's somewhat difficulty to understand and somewhat difficulty to remember this huge statement. Because of that I have reduced it to two lines. It's a simple statement. So this is for any bilateral network in the sense at least minimum two or more sources. So that one is called a bi in the sense two. So that's why here two sources are there now, that's why we can call as a bilateral network. So that bilateral network we can check the individual sources performance. That is the simple statement. For any bilateral network we can check the individual sources performance. It's a simple statement. You remember this is the circuit already I have shown in kit. The same circuit diagram I am going to take here. So here we are going to vary the voltage 0 to 30 volts, but here input I have taken I will be going to take 15 volts, 15 volts, either this end also 15 volts only and this second side also I am going to take only 15 volts. So here you remember I am going to take both end voltages 15 volts only. Because of that I am going to calculate the entire conditions here. So here you remember we are going to calculate this superposition theorem in three cases. So in first case you remember when source V1 acting alone, it's mean V1 source only we are going to take, and at that time V2 is in short circuit condition. It's mean in V2 is in short circuit condition. Whenever we are taking short circuit condition, at that particular condition voltage is simply 0. That's why V2 is 0 and V1 only acting here 15 volts. Okay, and remaining 82 ohms R1 resistance and R2 resistance 47 and R3 resistance 100 ohms are remaining. Entire circuit is common. Okay, for practical diagram we need to measure only what is the current value across these, I mean in series with this R2 resistance, because whenever this resistance is this source voltage is acting alone, this voltage is in short circuit condition, this current only flowing through this ammeter. Okay, and whenever we are taking this source is in short circuit condition and this one is acting alone, I mean V2 source acting alone, then at that particular condition also the same current flowing through this middle only. So that's why I am going to take only this ammeter. So for measuring purpose I am going to take here also one ammeter, that one is a I1, and here also I am going to take one ammeter, that one is a I3, but majorly you have to observe only middle ammeter values only. So according to our calculation You remember this is the calculation part for case 1. So in this case we are going to calculate R equivalent resistance. So where we are doing actually short circuit, so this V2 only we are doing a short circuit condition. That's why we are going to take resistance from this end to this end. So this end to this end, in the sense these two resistances are parallel, and these parallel resistances, this R1 resistance is in series. Because of that I am going to take for a parallel resistances 100 into 47, this 100 into this 47 by this 100 plus 47, that one only the parallel circuit resistance we are taking, plus series, in the sense for these two resistance, this 82 is a series resistance. Okay. So we are calculating entire this one, we can get it 113.97 ohms. Okay. So total current IT is equal to whatever it may be the source voltage we are taking, that source voltage by equivalent resistance. So this is the equivalent resistance. So I am going to substitute these two values, 15 by 113.97, in the sense we are getting 0.131 amperes. Okay. So here first we are doing short circuit for V2 and we are calculating the I1 current. So what is the I1 current? So it's mean from this, what is the current flowing through this ammeter. So that one we can take as a I1 current. So I1 current is equal to total current of this one into opposite resistance by total resistance. How we are taking this opposite resistance? Where we done the short circuit, for that short circuit opposite resistance we are taking. So for this short circuit opposite resistance is R3. So that R3 by total resistance of this R3 and R2. Okay. So total resistance. So IT is equal I1 equal to IT into R3 by R2 plus R3. So we can substitute all the values. Already we got IT value, that IT value is 0.131 into R3 value is 100 ohms by R2 is 47 and R3 is 100 ohms. Then we can get it 0.089 amperes. So this is the case 1. Okay. Then we will go for case 2. Same. Similarly here V2 is in acting condition and V1 is in short circuit condition. Whenever we are doing that short circuit condition, so that value is simply 0. V1 is 0 here. So this is the condition here. So second condition is V2 is acting alone. At that time first source V1 is in short circuit condition. Because of that V1 is equal to 0. Okay. You remember here V1 is equal to 0. So V2 is acting 15 volts. Remaining resistance all are same. Okay. So this is a theoretical circuit diagram and this is a practical diagram. What is the difference between these two? In the sense one ammeter is added middle resistance. Okay. You remember here also same, we are going to calculate the R equivalent and IT current and I2 current only we are going to calculate here. So R equivalent, in the sense we are calculating R equivalent from which side we done the short circuit, from that end. It's mean previously in first case we done this side short circuit. Because of that we done equivalent resistance calculation from this side. Right now we done the short circuit at this end, it's mean first end. Because of that we are doing equivalent resistance calculation from this end to this end. So that's why here I am going to take opposite resistance, whatever the resistance we are taking here, these two resistances are parallel. So for a parallel 82 into 47 by 82 plus 47. Okay, these two resistances. So parallel of these two resistances is in series with this 100 ohm resistance. So that's why 82 into 47 by 82 plus 47 plus 100 equal to 129.97 129.87 ohms. Ohms only we are going to take it. So IT equal to V1 by R equivalent. So V1 in the sense same 15 volts here, here we are going to take it. This one is not a V1 basically, this one is a V2 value. Okay. So that V2 voltage also we are taking, I have taken only 15 volts. So that 15 volts substituted here, and total equivalent resistance we got 129.87. So from that we got 0.115 amperes IT current. So I2 here we are going to calculate. Previously I1 we calculated, because I1 so first source we have taken, no, that's why I1 calculated previously. Here second source we are taking, no, here, that's why we are going to calculate for I2 current. So I2 current is equal to total current into opposite resistance by total resistance. So which side we done short circuit, from that side only we are taking opposite resistance. So here this is the short circuit condition. For this opposite resistance is 82 ohms. So 82 ohms by total resistance of these two. Okay. So total current into opposite resistance by total resistance, that is equal to IT into, total current into I1 by I1 plus I2. So this one is a I1 and this one is a I2. So I1 by I1 plus I2. So we can substitute all the values, 0.115 into 82 by 82 plus 47, in the sense we can get it 0.073 amperes. So this is the calculation for second case. Okay. Then we are going for third case. Third case is very simple. Already we are in third case, when both V1 and V2 sources are acting at a time. So it's mean previously we done V1 one time short circuited and V2 one time short circuited, but here both the sources we are taking 15 volts. Then what is the current I value? So I equal to I1 plus I2 simply. So already we calculated I1 value and I2 value theoretically. So I1 equal to 0.089, I2 value is 0.073. We can take sum of these two I1 and I2 values, we can get it 0.162 amperes. So these 0.162 amperes we can get it in this particular circuit when both the sources are acting 15 volts. So that one only the experiment theoretical calculation. Then we are going to connect the circuit practically. So here you remember, here one I1 current source is there and I3 current source is there, I2 current source is there. So these two sources also we are going to connect here, two ammeters we are taking to measure, but majorly you have to observe this current only. This current only, according to our theoretical calculation, these current only are very, very important to observe it. Okay. Then you remember I am going to connect one ammeter here, another, okay, and middle ammeter I am going to connect at middle, first terminal for first terminal and second terminal for second terminal, and third ammeter I am going to connect here, first terminal for first terminal and second terminal for second terminal. And here you remember power supply I am going to connect positive terminal for positive terminal and a negative terminal for negative terminal. So by using this regulator we are going to take a 15 volts here, you remember, and in first condition voltage V1 is acting alone and V2 in short circuit condition. That's why I am going to do this V2 is in short circuit condition. You remember this one is a shortage. Okay. Then I am going to turn on the power supply. You remember I am going to check here. source voltage. You remember here 12 volts, 12 to 13 volts only there. So then I am going to vary this one by using regulator. Remember 15 volts. So here we got negative. So why here we got negative in the sense here polarities are interchanged. Then we got positive. You remember, then we got positive right now. So here exactly 15 volts. So here little bit high voltage. So you remember for a 15 volts source voltage I have given. So what we got at middle ammeter, we got it 19.7. So here 19.7, this one is a milliammeter, so that's why 19.6 into 10 to the power of minus 3. Then only we can get it in first condition. In first case, what is the value we got it? I1 value, eventual value I1 equal to 0.089, approximately 90. Okay, so here we got it 90.7 into 10 to the power of minus 3. 10 to the power of minus 3 in the sense 0.09. Okay, so approximately 0.09 and 0.89 both are same. Okay, theoretically and practically. Okay, then I am going to vary for a second circuit, same power supply, same 15 volts I am going to take it, but first source in short circuit condition, first source in short circuit condition, you remember I have done, and second source only acting here 15 volts. So 15 volts. Then I am going to turn on the power supply here. You remember same 15 volts. 15 volts, same 15 volts, a little bit high. You remember 15.07 source voltage. On second side, whatever I mean, V1 side is in short circuit condition. Okay, you remember here we got in middle ammeter we got 77.7. Okay, 77.6 into 10 to the power of minus 3. Then we can get it 0.077. So theoretically you can observe in second case, what is the I2 current we got it 0.073. So we got practically 0.077. Okay, but here we got 0.073, a little bit 0.004 only high value we got it little bit. So that little bit value is not a huge variation, you remember. Okay, then we will go for taking a two voltage sources acting 15 volts. Connected 15 volts voltage source, and the same voltage I am going to connect from this end also 15 volts. Okay, so V2 source also I have connected here, and V1 source also I have connected here. So both the ends we are going to give 15 volts. Then what is the reading, you have to observe it. So you remember I am going to check it here. okay, 15 volts. So V1 is 15 volts. Then I am going to take second source side also 15 volts. You remember 15 volts. Then what is the exact value here? What is the exact value here? 166.6 into 10 to the power of minus 3. It's mean 0.166 final value. Okay, whenever two sources acting 15 volts. Okay, that one is a third condition. You observe it. Third condition. Whenever both V1 and V2 sources acting at a 15 volts at a time. Okay, then what is the value here? 0.162, but we got 0.166, just a little bit vary only compared to theory and practical. So I is equal to 0.162, we got it at middle of the ammeter. So practically and theoretically we have proved superposition theorem.